In this lesson, we're going to rewrite 5 cos x minus root 2 sin x in a different form, this time k sin x minus alpha. If you're asked in the exam to do it a certain way, then you must do that to gain marks. However, if you're not told which formula to use here, you can pick. You can either do k sin x plus or minus alpha, or k cos x plus or minus alpha. It doesn't really matter which one you use if you're not told. But let's have a look how it works with a sine instead of a cos. So the starting point is exactly the same. We're going to write k sin x minus alpha. We're going to expand it using the addition formula. So addition formula states that sine of x minus alpha will be sine cos cos sine, and the takeaway stays the same. So sine cos cos sine. I'm then going to rewrite the cos alpha at the front and the sine alpha at the front as well and multiply through by k. So k cos alpha sine x minus k sine alpha cos x. So let's look at comparing coefficients this time. Now, firstly, let's look at k cos alpha. That's the bit in front of the sine. Now you should notice this is different now because the coefficient of sine x is in the second part here, not the first part, because we've got this sine cos cos sine going on. So the coefficient in front of sine x is root 2, but there's a negative there, so it's negative root 2. And that's what we have to write. Negative root 2. This is where people get mixed up. We now look at the coefficient of cos x, which is this part here. Now, if we look at this part here, then we look up and we see a 5. So k sine alpha is equal to positive 5, but there's a takeaway in front. So we need all of this to come to positive 5. So k sine alpha has to be negative 5, so that takeaway, if you like, changes it all to a plus to make a positive 5 up here. So that bit there has to be negative 5. I would practice this if you're not sure of that. Find some examples like that and practice it until you're confident. Divide through by k with both parts and then do your Pythagoras. So cos is equal to adjacent over hypotenuse. This is your adjacent, so it's negative root 2. That's your hypotenuse, so it's k. And sine is equal to negative 5 over k. That's your opposite and hypotenuse, so negative 5. Pythagoras again to find the amplitude of the new wave. So the square root of negative 2 squared plus negative 5 squared. And that comes out as root 27. Now you could convert that into root 3 times root 9 and then 3 root 3. I've not done that here, but you could do that. So I'm just going to again copy these two examples down here to do the angle part or the alpha part. We look to see that the cos is negative here, and we tick what quadrants cosine is negative in. So that would be here and here. We also see that sine alpha is negative 5 over k. So sine is negative here and here. So we're looking at a third quadrant value for alpha. So looking at our right angle trigonometry here, then we've got tan is equal to negative 5 over negative root 2. So we'll write that down. To work out our base angle, or relative acute angle, we always use the positive value here. So inverse tan 5 over root 2, and that comes out as 74.2. To get alpha, you need to go forwards from 180 to get into the third quadrant. So forwards from 180, add it together and get your third quadrant answer. So again, k is equal to root 27 and alpha is 254.2. Make sure you look again that you're using the sign, so look up to the question and see what you're meant to be doing. You've got to write it in this format here, so put your k there and your alpha there at the bottom. Make sure you state this.